worked there. Then over, then over. Ugh. Okay. There are some things that are definitely missing here in terms of our ability to figure out what's going on here. Okay. So one thing here I want to just do here is display the step before we go into each of these. Yep, so we're going to go left. We just went left, then we went down, down. Okay. All right. Let's get like the first 40 of these and hope that it takes a step that I want to debug here. Yeah. All right. It goes left, it goes down. It goes down, it goes right, up, left, down, up, right, down, right, up, down, down, up, down, right. Yep, that is a down, so it's appropriately blocked there. Left, right, down again, up. Almost correct. The boxes moved, but we didn't. That's a bug. That's really glad I did that little bit of manual testing there because that would have been annoying. All right. So what happens, right? If we move in those directions, oh, so okay. We have to, right, we move that thing in the direction. Oh, of course, we didn't adjust our thing there. We then need to go ahead and swap, pause, target, return target. All right. And now I believe enough in this to give it a try. So let's go ahead, remove our spurious stuff here. Remove our little program shortener. And we're just going to say display big state at the end of this. Run. Okay. And then let's take a quick look at what it thinks the big state should be at the end of part 2 here. Scale to version of the large example. Oh no. This looks rather different than the scared up version of the larger example. Let's do a run all just to make sure there's crosstalk because the run all worked correctly. Okay, I'm not going to try to solve out my crosstalk, but we do need to be aware that there's crosstalk because something was not fully independent state across state. But look at that. That is so cool. Okay. So now switch the data set. And let's go ahead and again get ourselves the final get value of the big state, which is again the same data structure as before. So we should just be able to say here, display big state, get value, big state, run all. Zero. Zero, really? Oh, yep. Sorry, we do need to do something else here because it's looking for a different kind of box. Easily fixed. All right. Clear output. Can I have a code cell here, please? You're a code cell, but you've gone weird. Okay, making code cells has gone weird. All right. Yep, that's definitely weird. I can't make a code cell anymore. Undo that. Okay, things have definitely become a little confused here. There's our get value here. Remove it from here. Okay, this thing's allowed to display its big state. This thing can be deleted. And then get big value, because we only care if it's the left-hand side of one of those. So there we are. Get big value, big state. Now run all. 7, 4, 3, 1, 2, 3. That's not the right answer. It's too low. Okay. Well, let's go back and let's first go to the partial data here and confirm that the GPS coordinates for the partial example work. 2420. Okay. So even though I have the correct configuration here, the new thing is not doing quite what I need. 9021 is what it should be. Just from one at the top. 5 from the left edge. Oh, from the edge of the map to the from the edge of the map to the closest edge of the box. It was the left edge before, right? Yep. Always just that is a subtle little bit of blah. Okay. So getting the big value, we still have a problem to solve to get the big value. So the map is the map. The value is okay. So as we walk this thing, okay, I think what I just want to do here is, yeah, C is less than width over 2. If that is there, also if map sub R sub width minus C is equal to one of those, we also do that. How about now? 2413. Why is that the case? Like map, yeah, my goal here would be, yeah, because width minus, we kind of want to be counting it from both edges. Actually, hang on. C less than or equal to width over 2. 3018, but it's supposed to be 9021. Okay, this is going to be annoying to debug. Okay. But we've got this configuration. So actually the first thing I want to do here is, again, if I rerun this, big state is currently correct. Then we run get big value. We get 3018. So now the question that we need to answer for all of these is what do we find Um, so let's go ahead and say, all right, let's try running that. 3, 4, 5. Why am I only seeing 7 boxes here? That's a problem. 3, 4. Yeah, 1, 2, 2, 2. It should be finding these at the same time. And yeah, there's no else there. Map R, width minus C. Okay, it is finding, yeah, 1, 1, 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, then 6, 4. And then this one here, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so you should find one more at the bottom there. Wait, and why is it finding that at 8, 1? 0, 1, 2, 3, 4, 5, 6, 7, 8. 1 should be this. Uh okay, maps of R, width minus C. Okay, so the question we've got here is what's going on with my rows? Something is weird here. Okay. So there's row 0. Yep. Okay, there's a bunch of data coming through. So now, row 0, we're seeing, oh yeah, that's expected. Row 1 dot dot. Oh, it's using width. It's using width. That's our problem. I forgot that height stays the same, but width does not. Let's go ahead and comment out some of these various prints because I don't think that we need them. I can put them back in if I don't have the results I want. Index was outside the bounds of the array. Okay. Neat. Let's start here. Okay, R0, and we get that almost immediately. Oh. Oh no. Wait. Oh no, wait, yeah. State.map. No, that's the map, yeah. Oh, I've got probably the width of the other thing on there, don't I? Yeah, where is... Oh yeah, big width equals... Oh, I probably didn't reprocess that after... Yeah, run all. That'll probably work now. No. Index was outside the bounds of the array. when we did get big value, right? Okay. Print RC, please. 0, 0. That was outside. Oh. Big width minus C plus 1. There we go. Printing way too much. 10919. Okay, I think I might know the problem there. Let me just check something here. I think I might not need this to be less than or equal to. And I think I definitely don't need these print statements anymore now that I know what's going on. 8889. 8889. We are... Okay. Let's turn on just the print statements that tell me what it's finding. Yep. 1 and 4. Oh, excuse me. Okay, yes. That at 1, 4. That at 4, 5, 6, 1, 7. Yep. 2, 2, and 2, 3. 3, 2. 3, 2, 3, 4, 3, 6. Yes. 4, 2. 4, 2. 4, 3, 4, 5, 6, 7, 4, 8. Yep. 5, 6. Yep. 6, 4. Yep. 7, 2, 7, 4, 7, 7. Yep. 8, 4. 8, 8, 8, 8. Yes. Okay, those all did the things I expected. Okay. The box shown below has a yes, and 5. 1, 2, 3, 0, 1, 2, 3, 4, 5. Right. 1 from the top edge. Okay. So why are these coordinates not... Because that is... These values look... These are all the right boxes we're finding now. Okay. We found the correct number of boxes. We are... The value... Right. And in both cases we compute it, it's the row times 100 plus the column, where the column is measured from either the left or the right. We haven't missed any columns. Come on. I did not expect the checksum to be the thing that kills me here. Okay. Come on. R0, R less than height, R plus plus. Right. No, so we're doing... Yeah. We add both of those if they matter. Right, print map R. Yeah, I don't need that at this point. Okay. Yeah, in both cases, if we find a box, we add R times 100 plus C. Okay. Rerun this. Yeah. 10, yeah, like these numbers are entirely sensible. One oh two, 102, 104, 107. All right, and then yeah, after each set of these, let's just go ahead and print the value as we're going here. I mean, let me just again, I want to double check for something sensible here because yeah, printing the values, like the math all looks like it's doing what I expect. Every time we find a box, okay. So we're going to print out how many boxes we've found. Yep, 21 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 boxes. Is one of my boxes subtly misplaced? Like, all right. Okay, printing that a little bit more tightly there. 4 between there. Yeah, 4 over to there. 2 there. No, this is exactly the same as what they've got, and the fact that they don't explain their summing. The sum of all these boxes' GPS coordinates is 9021. Um, and this is the bit where the fact that I'm really not good at arithmetic has me worried because this is not the kind of thing I am normally particularly good at finding of myself. Okay, we're gonna find this. This is me officially asking for support from chat if anybody thinks they see what's going wrong, because we're into thorny debugging, not into fun problem solving. So if anybody thinks they see what I'm doing wrong, I will take it. I mean, yeah. The sum of all boxes their final coordinates. Yeah, the coordinate is a number. It's not really a coordinate, it's just a number. 102, 102, 10. I mean, I have no reason to believe that this value plus equals code would be doing anything wrong. And these are all reasonably calculable. And this problem's been here for multiple days, which makes me think that if there's a bug in it, somebody would have already called it out. This doesn't feel like the sort of thing that they would choose not to update. And it's not the sort of thing that would be missed because I'm not the only person who uses this data to test. So what have I done wrong? Yeah, that looks exactly like I expect it to. The numbers match what I would compute by hand. We are never given an example of a right hand move. How far off am I? 8889. $9021 minus 8889. Hang on there. Yeah, 9021 minus I have 8889. We're off by 132. That's not like even an off by one in how I'm calculating some of these things. Yep. Okay. Twice as wide, wide boxes. Okay. Right. Like we've got all of that stuff going there of how that works, but then right. Distances are measured from the edge of the map to the closest edge of the box in question. Which definitely means I should be looking at the right edges, not just the left edge. Yeah. And we're off by enough that, yeah, with 21 boxes, I mean, hang on, 132 divided by 21. Yeah, we're off by an average of 6 points a box. Obviously, it'll be more for the higher valued boxes, I presume, but 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Oh, the top edges work the same way. The edge to the it's not just the left right because that's the one it's doubled on, it's also the top edges. Okay, fine. But that doesn't make sense. Oh, to the that should reduce the numbers because that would mean, shouldn't it?